Ever wondered how your smartphone knows the phone's orientation? It's one of the coolest features of today's smartphones. They all got a tiny device, called accelerometer, built into the circuitry, which can sense when you tilt it from side to side. That's how your smartphone automatically figures out when to switch the screen layout from portrait to landscape. Accelerometers are widely used in cost-sensitive, low-power, motion and tilt sensing applications, like mobile devices, gaming systems, disk drive protection, image stabilization, and sports health devices. In this project, we are interfacing ADXL-335 tilt sensor with Arduino UNO. We will display the reading of tilt sensor on the LCD display. Here is the connection diagram of this project. 16x2 LCD display has 2 lines. Each line can display 16 characters. This display has 16 pins. First pin is ground, second is VCC, then contrast, RS, RW, enable, D0, D1, D2, D3, D4, D5, D6, D7, VCC, and ground. Pin 1 and 2 provide the supply for its internal circuitry, and pin 15 and 16 provides the supply for its backlight. We have connected pin number 1, 5, and 16 with the ground pin of Arduino, and pin number 2 and 15 with the 5V. Pin number 4 of LCD is connected to the pin number 12, and pin number 6 of LCD is connected to the pin number 11 of Arduino. Pin 7, 8, 9, and 10 are not used. Pin 11, 12, 13, and 14 of LCD display are connected to the pin 5, 4, 3 and 2 of Arduino respectively. Tilt sensor ADXL-335 has 4 main pins: VCC, ground, X out, and Y out. X out pin is connected with pin number A0 of Arduino. Y out pin is connected with pin number A1. VCC pin is connected with the 5V pin, and ground pin is connected with the ground pin of Arduino. This is the code of our project. To control the LCD display, we will first include its library in the program. To include the library, we will write in the first line, #include liquid crystal.h. Then we will declare the name of the used pins, in the sequence of RS, enable, D4, D5, D6, and D7. We have connected RS pin of LCD with pin number 12 of Arduino, D7 of LCD with pin number 2 of Arduino. X out pin of sensor is connected with pin A0 of Arduino. Y out pin of sensor is connected with pin A1 of Arduino. Now we have declared 2 variables, X ADC value and Y ADC value. These variables will store the output reading of the sensor. Void setup is a function in which we have initialized the LCD. LCD.begin 16,2. It means we are using 16 columns and 2 rows of the LCD display. Void loop. This function will run over and over again, so whatever we write inside, it will repeat forever. X ADC value equal to analog reads out. It will read the value of sensor pin connected at A0 and store in the variable X ADC value. Similarly, Y ADC value equal to analog read Y out. It will read the value of sensor pin connected at A1 and store in the variable Y ADC value. LCD print X ADC value. It will print the readings on the LCD display. LCD set cursor 0,1. It will print the message in the next line on the LCD display. LCD.print. This function will print the message written inside the brackets on the LCD screen. Delay 500. This function will generate a half second of delay. Now, we will write a code on this software. After writing the code, we will save our project. Now we will compile our code. For doing this, press this check button. If there is any error in the code, or the code is incorrect, it can be seen on the message screen below. If the code is correct, we can upload it to our Arduino hardware board. For this, we will first connect the Arduino board to the USB port of our computer. Now we will go to the Tools menu, and select Arduino UNO. Then, we will go to the port option, and select the port at which Arduino is connected. Now, to transfer this code to our hardware, we will press this arrow button. Now we will assemble our hardware. We will take 3 wires, 1 red, and 2 black. We will use these wires later. Now we will solder a black wire at hole number 1, and red wire at hole number 2 of LCD display. Now we will solder a white wire at hole number 4, and brown wire at hole number 6 of LCD display. Now we will solder orange, yellow, green, and blue wires at pin number 11, 12, 13, and 14 of LCD display. Now connect hole number 16 with hole number 1 using a black wire, and hole number 15 with hole number 2 of LCD display using a red wire. Now connect hole number 5 with hole number 1 of LCD display using a black wire. Now connect hole number 3 with hole number 1 of LCD display through a 1 kilo ohm resistor. Now we will connect the LCD display with our Arduino hardware board. Connect the red wire with 5-volt pin and black wire with the ground pin. Now connect white, brown, orange, yellow, green, and blue wires with pin number 12, 11, 5, 4, 3, and 2 of Arduino respectively. Connect a red wire at VCC pin, black wire at ground pin, green wire at X out pin, and a yellow wire at Y out pin of the sensor. Now connect the red wire with 5-volt pin of Arduino, black wire at ground pin, green wire at A0 pin, and yellow wire at A1 pin of Arduino. Now we will power up our circuit and test its functionality. We can see, as we are tilting the sensor towards left or right, the readings on the LCD screen is also changing. I hope you enjoyed the video and learned something from it. For any help in your project, or to clear your doubts, you can contact us on our student care number 7007957715. To purchase the items used in the video, you can visit our website www.erolltech.com. You can order us on our WhatsApp number also. Thank you so much.